It's all about you, Camtasia.
You want to just cut that part out? Or you want to start over?
Ready and go.
All right, so section 5.5, law of signs. First, we need some background info, and it's actually going to be background info for 5.5 and 5.6. So if 5.5 is a little longer than 5.6, that's why. We're setting up the stage for both. Basically, we talked in chapter 4 about right triangles.
That's a lot of chapters going on right now, but yes, you are correct.
In chapter 4, we talked all about right triangles. Hey, guess what? Not all triangles are right.
No! What?
I know.
Ay,
Some of them are this other word called oblique. Oblique triangles are triangles that have no right angles.
Are you making this up?
No, I'm not. It's
Are you?
really,
Do you promise?
I promise.
Is it on Wikipedia?
I don't know.
Everything on Wikipedia is true.
I don't know if it's on Wikipedia.
Okay, all right.
Without a right triangle, we cannot use SOHCAHTOA to find the missing sides or angles. We can't use the fact that sine of the angle equals opposite over hypotenuse because we don't have a hypotenuse because we don't have a right angle.
It only works with right angles.
Right. So, and here's 2 examples of what those oblique triangles can look like. A couple of examples. So, what we do is we have to come up with something else. So the triangle congruence stuff we did in geometry. This
Way
is
back
kind of
when, last year.
An introductory thing. We talked in geometry about how there's 4 types of triangles that you can say are always going to be congruent if you know this information.
Right.
So if I know an angle, and a side, all triangles with that angle, and side will be the same triangle.
No matter what.
Okay, same with angle, side, angle. So angle, side, angle.
Doesn't matter how you twist the triangles, this is what it does.
If it has that angle, side, and that angle, it will be the same as all other triangles with that angle, side, angle.
Right.
Side, side, side works. Side, angle, side works. And so for...
Angle, side, side, though.
Right, and I'm not going to write it out. I'll write it backwards. What we talked about in geometry is that this one does not show congruence.
No.
Okay, and we'll talk more about that case in a little bit.
That is correct.
For angle, angle, side, and angle, side, angle. And sometimes with SSA, we can use what's called the law of signs to solve the triangle. That's weird that showed up twice. Okay, well, sorry about that. It's not twice on yours, I don't think, but it's twice on ours. Down here is the law of signs. You can write it either way with either the signs on top or the signs on bottom.
The ratio is what's important here.
Right, that the sign of angle A goes with little a. And the way you set up the triangles is the angle A, we use capital letters for angles, and then across from angle A is little a. Across from, this would be B. Across from angle B is little b.
Just like you did in geometry.
Across from angle C is little c. And the C, big C, little c gets a little tough, but they use the alphabet, so what are you going to do? So, what, you want to just jump in and try a problem?
Let's go for broke. Jumping.
Oh.
Let's hide. Do some hiding.
Do some hiding. Okay, example 1. Solve triangle ABC given that B equals 15, C equals 39 degrees, and B equals 52 degrees. This is angle, angle, side, so we can do the law of signs. So what we're going to do is,
once you set it up, you'll also know if it's going to work.
Right. I like putting sine on top.
You know, whatever.
Okay.
I don't have a preference. It's all math.
Okay, so sine of angle A over, we don't know side A, equals sine of angle B, which is 52 degrees, over side B, which is 15, equals sine of angle C, which is 39 degrees, over side C, which is this one over here. Now, I put in a variable here we actually can figure out really quickly without actually using some fancy new thing. Use a fancy old thing, 39 degrees plus 52 degrees plus angle A has to add up to 180.
I'll just punch it in. 180 minus 39 minus 52, carry the 7, multiply by 36, 89.
He was kidding about those last couple of steps. So instead of having a big A there, we can say A is
your mama.
89 degrees. No.
Oh, okay, sorry. No, your mama jokes.
No. So where this A is.
Wow, that was a smudge.
Where that A is.
That was like a fingerprint on the door.
89 degrees. And
okay.
now.
Oh, can I?
Yeah,
look,
go.
if you'll just like check this out. We can solve for the 2 remaining variables, which means that law of signs is going to work.
Yeah. If we can't, then...
If we can't, law of signs won't work.
Right, but what we're basically going to do is look at this separately. We can look at this part of the law of sines right here.
Right.
Cross multiply.
Right.
And then solve for a.
Right.
So a times sine 52 degrees equals 15 sine 89. Put this in so that you don't end up rounding. Do 15 sine 89, enter. Divide by sine 52 so that it does answer divided by sine 52.
We want to be as exact as possible,
As
but we're getting
exact
decimals.
as possible.
And you should get to the 100th decimal place exactly what we get. And if you don't, you truly do have a rounding error issue. So
100th or 1000th?
1000th. What did I say?
You said 100th.
1000th. Third decimal place. So 13.075, or if you round up 6. Those are the only
5
two
or
things it
6.
could be. You cannot have 13.08. That is incorrect for this problem.
Right, because, yeah, there's no reason to round. Now we would use the other part of this. Let's do a nice, how about spring for our color?
Spring. Do the other side.
Do the other side. So cross multiply here. C sine 52 degrees equals 15 sine 39 degrees. Hey, by the way, I hope your calculator has been in degree mode this whole time. Otherwise, this is not going to work out very well.
Need to have positive numbers here. Positive numbers. Is that sine 39?
Maybe. Yeah.
Yeah.
Sine
Okay.
15.3.
What?
15 sine 39 divided by sine 52.
Gee willikers. 15 sine 39.
Right, because we divide by sine 52 on both sides.
52. 14.652.
14.652
Or 14.653.
or 3.
Okay, rounding according to AP standards.
Right. Round or truncate. So we knew 3 things. We now have solved 3 things. We know everything for this problem.
For this problem.
Right. So
Okay,
there's
good talk.
example 1.
Good talk.
Go ahead. Go.
All right, I'm on it.